Hi and welcome back to the Code in Action series. In this video, we're going to build yet another classic command line interface puzzle game in Node.js called the Minesweeper. And for those of you who've never played it before, here's the gist of it. The game is played on a square grid of a given size, where each square is initially hidden and contains either a number or a mine. To win, the player must reveal all the squares that contain a number without landing on a mine, as otherwise it's game over. These numbers go from 0 to 8 and are used to indicate how many of the touching squares around the revealed square, including diagonals, contain a mine. Finally, the player can also win by successfully guessing and flagging all the hidden squares that contain a mine. And for those who are interested in playing around with the code, it will be available for download in a couple of days on the Learn Backend website, link in the description below. And with that being said, let's build. So let's start by creating a new file named minesweeper.js in our text editor. Within this file, let's create an entry point using an immediately invoked function expression. Above the entry point, let's define a first function named createGrid that will be used to generate a new square grid of a given size. For now, let's just set the size to 6 and create an empty two-dimensional grid using nested arrays, where each subarray element, or in other words, each square, contains an object with the following properties, where mine indicates whether the square contains a mine, adjacent indicates how many mines are around it, revealed indicates whether the square was revealed, and flag indicates whether the square was previously flagged. Let's not forget to return the grid array, and finally, let's invoke this function within the entry point. Now, in order to make our script slightly more dynamic, let's create another function named parse_grid_size that will be used to convert the value of the third command line argument of the script into an integer that represents the grid size and either returns 6 by default if the size is invalid or not comprised between 3 and 10, or the defined size otherwise. Let's now update the signature of the createGrid function by adding a new size parameter to it, remove the hard-coded size value we initially defined, and invoke the parse_grid_size function within the entry point without forgetting to pass its return value as argument to the createGrid function. Now that we have a dynamically generated grid, let's move on to the next part, placing random mines. Let's start by creating a short helper function named generateRandomNumber used to return a random integer in a range. Let's now define a function named placeMines used to randomly place a certain number of mines in the grid, this number being equal to the size of the grid, which means that if the grid is a square of size 6, it will contain 6 mines and so on. Let's now define two constants named min and max and respectively initialize them with the lowest and highest indexes of the grid array. Let's also declare another variable named mines to keep count of the number of mines already placed in the grid. Let's now use a while loop that at each iteration will generate a random row and column number, check if the square at this position doesn't already contain a mine, place the mine, and increment the mines counter by 1. Finally, let's invoke the placeMines function within the createGrid function to update the grid. Now that the grid contains randomly placed mines, we need for each remaining square to compute the number of adjacent mines placed around it. So let's create a new function named placeNumbers that will browse every single square using nested for loops and immediately skip the ones that contain a mine. Let's then declare a constant named deltas that contains the list of all the relative positions of the squares around, where the first element represents the top left square, the second element the top square, the third element the top right square, and so on. Let's now use a for loop to iterate on each of these relative positions and immediately skip the ones that would be located out of the grid's boundaries. Let's then set up a count variable to keep track of the number of mines contained in the surrounding squares and update the adjacent property of the current square with a count once the loop terminates. Finally, let's invoke the placeNumbers function within the createGrid function to update the grid with the numbers. Now that our grid generation process is complete, let's create a few more helper functions used to clear the console, output a welcome message, output a command prompt, and output the formatted grid. So let's start by defining a function named clearScreen that, when executed, will write the following ANSI sequence to the standard output, in turn causing the console to clear any previous output. Let's now define a second function named printWelcome that greets the user and outputs the command that will be used to play the game. Third, let's define a function named printPrompt that simply outputs a special command prompt for the game. And last but not least, let's define a function named printGrid. Within the function's body, let's first output the column numbers and the top grid separation line. Let's then start a for loop that for each row outputs the row number, the state of the square, whether it's hidden, revealed, flag, or exploded, and the right grid separation line. And finally, let's output the bottom grid separation line. Once we've done that, let's invoke each of these functions within the entry point in the following order. So now when we launch the script, you should see something similar appearing in your terminal window. Now that we've completed the grid generation and grid display processes, it's time to handle user input. Let's start by setting up an event listener that will execute a callback function every time the standard input stream receives a data event, or in other words, each time the user presses the enter key on their keyboard. Let's now convert the received input into a string and clean it by removing any potential whitespace and newline characters before and after it. Next, let's use a regular expression to match and capture the following pattern from the cleaned input line, which can be read as follows. Match any string that starts with the letter R or F, followed by a number, a comma, and ends with a number. Then capture the letter and the numbers. Once we've done that, let's add an if statement that outputs an error message and resets the screen if the input doesn't match the regular's expression format. On the other hand, if the input is valid, let's parse and assign the captured elements of the regular expression to explicit variables. Let's then check if the position of the square at the specified row and column indexes is out of the grid's bounds, which means negative or greater than the grid's last index, output an error message, and reset the screen. Alternatively, if the square's position is valid, let's clear the console, mark the square as revealed if the specified command is R, output the updated grid, define a loose condition that outputs a game over message and immediately terminate the process if the revealed square contains a mine, and finally output a new prompt if the game continues. Now that we've defined our loose condition, let's create a new function named checkRevealedSquares that returns true if all the squares without mines have been revealed and false otherwise. To do so, we'll simply use a couple of nested for loops to iterate on each square, increment the counter by 1 each time a square is safe and revealed, and compare the counter to the total number of safe squares available in the grid. Finally, let's move back to the entry point, invoke the checkRevealedSquares function as an alternative to the loose condition, and output a win message and terminate the process if it returns true. Now that we've implemented the square revealing logic, let's implement the second mechanism of this game, flagging. At the top of the entry point, let's declare a new variable named flags that will keep track of the number of flags available and initialize it to the total number of mines present in the grid, which, as a reminder, is equal to the size of the grid itself. Now, within the condition that handles the reveal command, let's add a condition that checks if the revealed square was previously flagged, unflag it, and increase the number of flags available. Next, let's add a new block that handles the flag command, and within it, 3 conditions. First, let's check if the square is unflagged and if there are no more flags available, and output an error message. Second, let's check if the square is already flagged, unflag it, and increase the number of flags available. And third, let's check if the square is not yet revealed, flag it, and decrease the number of flags available. Let's now define a new function named checkFlagMines that returns true if all the mines have been correctly flagged and false otherwise. To do so, we'll implement the same logic as for the checkRevealedSquare function, which means setting up a counter, iterating on each square, incrementing the counter each time a square containing a mine has been flagged, and comparing the counter to the total number of mines present in the grid. Once we've done that, we can move back once again to the entry point and invoke this function as a win alternative to the checkFlagMines function. Now that we have a fully functioning game, it's time to add some score tracking capabilities to it, which naturally starts with allowing the player to define their username. So let's start by slightly modifying the print welcome function so that instead of outputting a message with the game commands, it asks for the player username. Then let's create a new function named print commands that outputs the game commands that were previously defined in the print welcome function. Within the entry point, let's declare a new undefined variable named username, and let's remove the first calls to the print grid and print prompt functions for now. Then, within the body of the even listeners callback function, let's declare an if statement that will only be executed if the username variable is undefined, update the value of the username variable, and print the game commands, grid, and prompt. And as you can see, when launching the game, we are now first prompted to enter our username, then the game starts. Now that the game registers our username, let's move on to the next task, keeping track of the score. Within the entry point, let's declare a new variable named score and initialize it with an object where time is used to store the number of milliseconds elapsed since the epoch at the beginning of the game, revealed is used to count the number of safe squares revealed by the player, flagged is used to count the number of mines correctly flagged by the player, and exploded is used to store whether the player revealed a mine or not. To keep track of the game start time, let's update the time property of the score object with the value returned by the now method of the date object as soon as the player enters their first valid command. Then within the winning-losing conditions, let's calculate the difference between the game start and now and divide it by 1,000 to express it in seconds. Next, to keep track of the revealed squares, let's increment the revealed property of the score object every time the square doesn't hold a mine within the condition that checks if the plate command is revealed. Then, to keep track of flag mines, let's first decrement the flagged property every time the number of flags available is incremented, which implies that the flag square was either revealed and therefore didn't hold a mine, or just unflagged. Then let's increment the flagged property every time an unrevealed square that holds a mine is correctly flagged. Finally, to keep track of whether the player exploded a mine while revealing a square, let's set the exploded property to true within the lose condition. Now that our game is able to keep track of the score, it's time we add a final touch to it by saving it into a file and outputting it along with a high score table at the end of each game. So let's start by defining a new function named calculatePoints that returns the total amount of points scored by the player by adding 10 points for each safe square revealed, 25 points for each correctly flagged mine, and a bonus of 100 points if none of the mines have exploded. Then let's create a new file named scores.json within the same directory as the script and write an empty array into it that will be used to store the scores of each game. At the top of the script, let's import the core Node.js fs module used to interact with the file system, and let's create a new function named updateScores used to retrieve, update, and return the list of scores contained in the scores.json file. Within the function's body, let's first declare a new variable named file and initialize it with a path to the file that contains the list of scores, declare a new variable named scores, and return the scores variable. Let's then declare a try-catch block that will be used to gracefully handle and log any potential errors that might be thrown while attempting to read, parse, or write the file. And within it, let's read the contents of the file, convert it into a JavaScript array, add the player score including their username, total amount of points, and game duration to the list of scores, and write the list back into the same file as a string. Finally, within the entry point, let's declare a new undefined variable named scores and update its value by invoking the updateScores function within both the winning and the losing conditions. Now that we've taken care of updating and storing the score, all there is left to do is to output it at the end of each game. And to do so, let's declare yet another function named printScore that outputs the player score as well as the 10 highest scores in the following format. Within the function's body, let's first output the player's username, total points, game duration, number of safe square revealed, and number of correctly flagged mines. Let's then sort the scores in descending order based on their amount of points, and alternatively, in case of equality, by game duration. Then only keep the first 10 scores, and finally output each score line by line. Finally, let's invoke the printScore function within both the winning and the losing conditions using the value returned by the updateScores function. Here it is for today, guys. If this video clicked for you, don't forget to hit the like and subscribe button and drop a comment below. Now, if you're new to programming, you should definitely check out my Skill Search Challenge, a beginner challenge designed to teach you how to write and run code, build real skills, and think like a real developer in only 21 days. And if on the other hand, you're ready to go pro with backend development, you can join the Learn Backend Mastery program, a complete zero to hero roadmap to become a professional Node.js backend developer in only 12 months. Thank you for watching, guys, and see you in the next one. Cheers.